So I was doing some experiments last night with my proximity sensor to detect metal object as it goes through the coil. So the experiment that I did was I hooked up a function generator to a resistor R here, and in series is the parallel LC. The L is the coil and the C is the cap. The LC creates a resonant frequency called F naught, and the resonant frequency is 1 over 2 pi square root of LC, which L is the inductance of the coil and C is the cap in parallel with that inductor. So the experiment that I did was I swept the frequency of the function generator. So as I swept the frequency, the behavior of the voltage across the coil here, this is the voltage across the coil, it goes up and then it peaks at this self-resonant frequency of the coil and the cap. And then as I increase the frequency, the voltage drops and so on and so on. So then as I put a metal object through the coil, I can see either the voltage increases or decreases based on the frequency that I excited the coil through the function generator. So for example, if I feed this coil at F of L right here at the low frequency below the self-resonant frequency, what happens is as the metal object enters the coil, the inductance drops across the coil. So you could see what's happening as the inductance drop. Well, the self-resonant frequency shift higher in frequency. All right. So as the as the metal object enters the coil, you can see the shift in the frequency response. And then what's happening is now, if I excite the coil at F of L, below the self-resonant frequency, you can see now the voltage drops, okay? The voltage drops from here down. Now, if I instead excite the coil of the using the function generator at F of H, which is a frequency above the self-resonant frequency, then what happens as the metal object enters the coil, you can now see the voltage increases. All right, so that explains some of the behaviors that I was seeing last night. I was expecting like why does the voltage drop or increase depends on the frequency that I excite the coil. This is the explanation. So you can play games in your proximity sensor to make the circuit behave the way you want it. You can either, make the voltage increase or decrease, depends on what you want to do. So if you want the voltage to increase as the metal object enters the coil, then what you want to do is excite the coil above the self-resonant frequency of the LC. But if you want the voltage to decrease, then you want to excite the coil below the self-resonant frequency. Now, one other interesting behavior that I saw was like, okay, why don't we just excite the coil at the resonant frequency itself? Well, as it turns out, depends on the Q of your component. The voltage drop is very minimum at around the center frequency. So it just depends on how much change in inductance as the metal object enters the coil. You may not see a lot of voltage drop if you excite the coil at the self-resonant frequency. So it's probably best to excite the coil either on the lower end or on the upper end of the coil to get the most dramatic effect, right? To get either the largest voltage increase or the largest voltage decrease for your sensor. That's it.